Okay, so here we have another differential equation. We have to try to solve, right? So let's see how we can do this. So the only difference with this kind of a differential equation is that we're writing this in Newton's notation instead of Leibniz notation. Now, I prefer Leibniz notation, so let's use Leibniz notation for this problem, right? And it's really easy once you can rewrite it. So this is just going to be dy dx plus x e to the y is equal to 0. So what we're trying to do is we're trying to separate this, right? So we just first need to identify if it's a separable differential equation. So we just need to separate the x's and the y's. So in this case, actually, we can separate the x's and the y's with some algebraic manipulation, but sometimes it's just not possible to do that. And in the case that, in the scenario where it's not possible, what you would need to do is you would need to use a variable substitution. Okay, so whenever you cannot use just algebra to separate a differential equation, use a variable to substitute it in, and it will work. So in this case, you don't need to worry about that. So this is just going to be dy dx is equal to negative x to the e to the y. We can multiply dx here and here. So dy is equal to negative x e to the y dy. So this is just going to be e to the negative y dy is equal to negative x dx, right? So this is what we have. If we integrate both sides, the integral of e to the negative y is negative e to the negative y is equal to, integral of this is just negative x squared by 2 plus c1. We can divide by negative 1, so this is e to the negative y is equal to x squared by 2 minus c1. Natural log of this is equal to the natural log of, natural log of this. So this is natural log e, so negative y is equal to the natural log of x squared by 2 minus c1. Divide by negative 1, so y is equal to negative natural log of x squared by 2 minus c1. So that's the solution. So don't you just love this algebra? Alright, so this is solving this differential equation.